thank you for coming to this talk and not talk about Gen AR or LLM or something like that. So thank you. My name is Alejandro, or Alex. I work at Tinybird, which is a real-time analytics platform. And during the last few years, I've been working in different data projects at different companies, and some of them have been about event sourcing. Most of them have been at large scale, so I've seen different things. And today I'm here to tell you about things I've learned and maybe some suggestions if you are considering this. So first of all, how many of you are familiar with event sourcing at all? 1, 2, 3, great. How many of you have implemented a use case in production? Interesting, thank you. So, interesting. So, I used to work at a large retailer for a few years, and I was involved in a number of different projects, all of them always around data, from those automated reports you get on your email first thing in the morning to more advanced things like mobile applications, chatbots, internal dashboards, a number of things. We built a cloud data warehouse from scratch before dbt was even a thing, so that was definitely interesting. And in the last 3 to 4 years, we built a event-driven architecture from scratch, and that was also very interesting. After that, I joined Tinybird, and I'm seeing very similar use cases across different customers that are also in this journey of building data-driven architectures and systems. So today I'm here to tell you some stories about that. I have a disclaimer for you. Some of the things I'm going to share today are personal opinions of things I've seen personally. This may not apply to you or your background or your use case, and you may disagree with some of them, which is perfectly fine. If you have questions at any point or you want to share something, you can just raise your hand, okay? If not, we are doing 5 minutes of questions at the very end. So, I know some of you are already familiar with the term, but some of you are not. So allow me to spend a couple of minutes going through what it is, so we can settle the proper ground for the next of the talk, okay? So in a more traditional, it's rendering a bit strange. Oh, that's fine. So what's event event sourcing? Event sourcing is a software design pattern that consists on storing changes to your application state as a sequence or immutable events in time. So in a more traditional setup, you will have your database, and if you have a bank account, let's say, and you want to know your balance, you will go to your accounts table, filter by your account number, and get your balance. In this example, I'm opening, let's say an example, okay? I'm opening my bank account and I'm depositing $5,000. So this is my balance. In an event sourcing approach, everything that's happening to my bank account is a series of events. So as I open my account and I do an initial transfer of $5,000, some event like this is just an example, gets generated. So I'm depositing $5,000. Let's add a couple of more events. So we have one of them for buying data council tickets. So $1,299, and I'm also buying the flight tickets from American Airlines, for instance. So what's my balance? Wrong question. What's my balance at some point in time? This is the interesting bit. So in this point in time, let's say, is my first event, $5,000, minus $1,299, that equals $3,701. Now, same thing, but with all of the events. So 5,000 minus those two transactions, 2,822. So basically, event sourcing consists on building the state of your application at some given point in time, applying business logic. So what use cases fit great in here? In my experience in these companies, I've seen different groups of use cases that work great with this. I'm bringing 3 groups here as an example. First one is about financial and accounting system. Having a complete log of transaction and actions is great for audit. And we even have customers that have built fraud detection systems and patterns to prevent fraud or suspicious activities. And the sooner you can react, there's more money in it. So this is great. Enables fraud detection in real time, for instance. The second one is about building security and observability use cases. So log analytics goes in here. We have some tech customers that are doing use cases in this space. For example, one of them has a web application firewall, a WAF. So they are ingesting a huge amount of log events, and they have a pattern to detect a denial of service attacks. Before doing this, their operating window, they could react within minutes, let's say 15 minutes. Now they can react within 5 seconds, something like that. So that means money that is not spent on AWS services. So reacting faster to eventualities is great for your business. So they are doing great with that. And finally, we have e-commerce and inventory management systems. E-commerce is a great example because we have great customers doing real-time personalization. So you have the actions that your visitors to your website do, like visiting products or adding them to the cart. And then you have your business model to do real-time personalization. So I'm adding these trousers to my shopping cart and these shoes, so I get recommended this t-shirt. Not tomorrow, not later today, next second. So that's game-changing for them. And another very interesting use case with Build is about inventory management and shipping and delivery optimization. Because now you have the full log of states your parcels go through. So we have people that have spotted inefficiencies in their shipping and delivering processes, like moving stuff on places they shouldn't be. And so as you move on larger scale, more business eventuality or edge cases happen. So having the full log for observability is great. So after building this, some things I learned. Before that, and to set the right context, this is like the standard or the scale we are operating these days. We have event sourcing use cases right now with these actual numbers with real use cases. We are doing around 500 megabytes per second in some of them. We are serving well above 15,000 requests per second for reads, and while keeping the average read latency under 100 milliseconds. So this is when I say at the scale, this is what it means mostly. So let's stay positive. So good things. As I said, full traceability. I've already explained this. This is great. You have the full log of things that happen to your company. This is brilliant. Let's say we are selling content subscriptions. So we have a use case, real one, that if you go and query this subscription ID, you will see it is suspended. But why? We don't know. If you keep the full log of events, you will see that someone created the subscription, it updated probably the payment method, it got rejected, and the subscription is suspended. So we've seen use cases that after implementing this, then the customer support team can go and contact the person in this case and fix it before it's suspended, or you can operate your business more in a real-time way. So full traceability is great. You can apply business logic changes retroactively. This is game changer actually, and I've seen this as well in a previous project. Your company will evolve, and the business criteria you use over years will change. If you store attribution things in your data, you may not be able to change your criteria. So a great example of this is an attribution model we built for one company. So this is an e-commerce company. You visit a category. This is our swag shop, by the way. you visit our shop, you see the new t-shirts we have, then you go and see the most popular items we have, like caps or whatever, and then you finally add something to the cart. If you wanted to build your funnel and attribution model and you want to attribute this sell to one of the categories, you must apply your business criteria, like the first category you sold the item in or the last one. In a more traditional model, you will store the category you choose in the transaction, and it's there forever. If you have the full log of events, you can apply that and build the state, or you can change your business criteria and test it. For example, again, in this project, we changed how category was attributed to a sale, and it was applied retroactively. So we could do back-to-back testing and test how changes in the attribution model could impact performance. So again, full log of events, but in this case, you can apply changes retroactively, which was great. As you move up in the scaling these kind of use cases, you will see that you need to have more producers and more consumers while you keep changing things in your business. You will for sure add new attributes to your entities over time. You may have non-backwards compatible changes when you drop attributes or you change types. So until now, if you roll out those changes, you have to coordinate producers and readers in some way. With this approach, you can start generating different versions of the same event. So you can have non-backwards compatible changes, roll them out, and then after that, without having to really coordinate that, you can roll out consumers that get the new version, and you can do that at your own pace. So this is great for schema evolution, and it will happen to you, in my personal experience. We have customers doing changes to their events every week or even day. So you may have heard of those positive things. Those are great. But the not so good things I've seen. The first one is quite obvious. It's about cost. This is actual numbers for a real use case. And we need to store 1,000 times more events or more disk. We need 1,000 times more disk to store the events. And we go from the current state, which is around 400 megabytes, to up more than 400 megabytes to more than 2 terabytes. So this increases storage costs and compute cost as well compared to a more traditional system. However, we've started to work, and we have those in production, use cases that use cloud storage. So as more technologies and systems are adopting cloud storage these days, this is no longer a huge issue, but well, this is something you have to account for anyway. And this is the big topic. I think some of you may be familiar with this. This is a choice you have to make, I think. If you go this way, you will have to deal with eventual consistency. If we are really purist, everything is eventually consistent. But you know, sometimes this is something I've seen in some critical use cases is sometimes it's better not to make a decision, rather to make it based on stale data. And that's very important. So you have to choose what's more important to you. Scalability and being able to have everything event-driven and async, or consistency if you very have strict requirements here. And this is something you hit during this journey, and this is something you have to consider. This is a non-obvious one, and this is something that some large customers are suffering from. It's once you go this way, you cannot do updates or deletes to your system. So day-to-day operations are way more complex. For example, in a business that sells online, for instance, you will have a customer support team. If you have an issue, you call them, they assist you, and they have a runbook to fix something for you. As you move up in more complex use cases, there are more edge cases you have to deal with. So now everything is an append-only log in a way. So you have to compensate for those by using compensation events. And you may need to build some custom scripts to deal with that. So everything gets a bit more complex. As well as reads. So this is a real example. Again, in the subscriptions use case, if you want to know how many subscriptions you have, you select the unique count of IDs, and you're OK. But this is the actual query we have now. This specific use case needs to have final states modeled, that if you receive that event, you don't care of what's coming next. You have to get the final states for each key, order in time. You need to join that. So you get the idea. Everything is a bit more complicated as you need to apply business logic, final states, and so on to the full log of events. Also handling duplicates. When you go back to the drawing board and you define your system, theoretically, you will say, the way I've designed it, I won't have duplicated events. And that's a mistake I've made in the past, to be honest, and some people I think you may have made already, and yes, it will happen, because exactly what semantics are extremely difficult. If when producing an event, it times out, what would you do? Would you send it again? Would you assume the reader may have it? You don't know. So you end up doing all at least once, I think, and you may need to handle duplicated events. And every single large-scale use case I've worked on, we had to do this. Hopefully, maybe that's not your case, and I'm happy for you. But that's not what I've seen. And this is the final one I have. When you start this journey, you don't know that much about your domain, how to model in your domain. So your first events and schemas may not be exactly what you need, and you probably made not great decisions at the very beginning. Since this is now a durable log, you may have to live with those initial schemas that are not exactly great for a very large period of time. And this means you may need to keep code just to handle all the events like almost forever, or at least for a long time. So dealing with all events that will never go away is a hurdle we've hit a lot of times. And that's it. So that's what I think it's the good and the bad parts. So now I'm considering that. I have some things I learned that if you are considering going this way would be my suggestions. Or put in other words, hot takes. And this is the controversial part. So I encourage you to please raise your hand if you disagree with something, because this might get fun. Okay. So the first one, don't do it. Let me explain. I'm not saying never ever do this. It's a bit clickbaity, I know, I recommend. What I'm trying to say here is, it's very easy to underestimate this journey. I've been in multi-year projects doing this, and every single people will say this is way more complicated than we thought. Way more complicated. It's not about technology. It's not about frameworks. It's not about databases. It's about a cultural and mindset change all across your engineering team. Everything is an append-only log now. That's a big change. You cannot query things right away. You have to build a state. So just the idea of building a state may be complicated. So if you need this, do it. But my point here is please consider all the trade-offs, because this is like building your own house. Most of the people I know that are building their own house will say, I'm not doing that again. So it's similar to that. Next one is, when you need to get metrics and answers for your business, you don't need data. And events are data. You need information. So you build a state, you apply business logic, and then you get information. What this means is you need a semantic layer on top of your events. Again, when I worked building a data warehouse, we had 3 layers in the original design. We have raw, which is raw events. We brought them in. We have foundation, when we model the business entities and we build the state. And then we have application layer, in which we have aggregations made for specific use cases like plotting charts and something like that. So when some business stakeholder would ask you any question or to get any metric, you won't go to the events, you will go to the semantic layer that is a stateful set of your business entities. Which takes me to the next hot take. It's you need a CQRS pattern. If you are not familiar with this term, is having a dedicated system for reads. Ideally, an OLAP analytical database as you have larger and larger scale. Here is where you hit the eventual consistency problem the most, because you have to have a separate system for reads. But they have very good synergy, or that's what I've seen, with an event-driven or event sourcing approach, because you can build this semantic layer and this state in a database or a system fully meant and designed for that. And that's not the only thing you may need. You may need snapshots as well, because, taking things to the extreme, you wouldn't even need a database. If you have a durable log or every single event your business has produced, you will be able to query that at any point in time. But good luck spinning up a new service and making it replay 10 years of events. So you may need, again, a CQRS system that has snapshots. Going back to the bank example, and some of you may be in finance, so please pardon me for this very simplistic example, but if you go to check the balance of your account, you wouldn't go through all your transactions in your entire life. You will go to the latest snapshot, maybe this tonight at 0000, and then apply the offset of events. So snapshots are needed for very large scale use cases, and that's what we usually do in our projects for our customers. This is my final point, and this is something we've learned from working with analytical OLAP databases, and it's that materialized views are awesome. I don't know if you guys are familiar with ClickHouse, which is what we use the most. It's an open source analytical database, and we leverage these sort of features they have to handle this building those states. And let me illustrate why I think this is awesome. You may have seen yourself in this situation in which a batch process or something like that fails in the night, and you have to rerun it. And then downstream, you have dependencies that need to read from that. So you need to manually rerun a number of things downstream. So as you start working with very complex, large-scale projects, this is a real, let me see if it works. No, it's not working. This should be a video. So this is a real use case. This is all the things they have in the actual project, and this is all the dependencies they have. So if this thing failed in the night and you have to rerun everything, you will have a hard time. The good thing with materialized views is they are fully handled by the OLAP database in this case. So as you push new data from here, it's fully managed. So my personal opinion is materialized views are awesome.